What's up, everyone? Sean with Create Your Lifestyle Academy, and in this video we're going to start off the series of chemistry tutorials by giving a synopsis of the scientific method, what it is, how you can use it, why it's useful in everyday life, because science is a mindset and science is a process, and I really want to share that with you all through this video. And this is going to kick off the series of tutorials in chemistry. But you got to know this first to keep it short and to the point. And so the anecdote I'm going to give you all is me getting coffee. I love coffee. I drink it every day. It tastes really good, and I get it with cream and sugar. And so when I go to Dunkin' Donuts to get my coffee, basically I get coffee throughout all the year, and I switch it up depending on the external temperature of the environment. And so just for simplicity's sake, we have the summertime and the wintertime. Get coffee in the summertime and the wintertime. And when it's summer, I get iced coffee, and when it's winter, I get hot coffee. And when it's hot, I notice that I'm unable to taste the granulated sugar inside my coffee. But when the coffee is cold, I can feel the granulated sugar on my lips as I drink the coffee. And I'll ask myself, why is that? I really do. I'm like, when I first did, I was like, oh, that's it's because when you feel coffee on your lips, you feel the sugar on your lips as you drink coffee, it tastes it feels weird. You just want to take coffee, right? So I asked myself, why is that? And what I've just done is I've executed the first step of the scientific method, which is ask a question based on observation. And so I want to figure out a way to get my question answered. And so basically I've got to find a way to rephrase my question in order to get a tabulated, quantitative, or empirical measurement of what my question is, because my question is kind of general, right? And so I need to rephrase my question, and I need to rephrase my question in such a way that it will subsequently allow me to execute a series of more steps to get the question answered, and I can share it with other people and say, this is what I've done, this is why I did it, and this is what the result was. And so what I need to do now is form a hypothesis. And a hypothesis comes, generally speaking, in the form of an if-then statement. And if that hypothesis is proven to be correct in multiple experiments, which is our next step, giveaway, if a hypothesis is proven to be correct in multiple replications of an experiment, it becomes a theory. Not a law, but yet it's a theory. And so hypothesis is an educated guess, if-then statement. I'm going to write that down. And so what's my hypothesis? I mean, based on the observation I made, I said, look, if I can't feel the sugar in the hot liquid, but I can feel it in the cold liquid, the temperature must have something to do with me being able to feel the granulated sugar on my lips as I sip my delicious, succulent coffee. And so, basically, I'm going to say, if I increase the temperature of the liquid, then there is a greater chance of the sugar going away. And, you know, we're going to be more scientific here, and we're going to say dissolve. It's going to dissolve. If I increase the temperature of the liquid, then the sugar will dissolve. Yeah, sounds about right. Okay, so I said if I increase the temperature of the liquid, then the sugar will dissolve quicker. Because although I can feel some of the granulated sugar on my lips as I drink the iced coffee, we know that I can't feel all the sugar on my lips. So there's some of the sugar must have dissolved even though it's cold, but we're varying the temperature here, right? And so that's why I phrase hypothesis in this manner. And so, continuing on, I need to conduct an experiment to test this hypothesis. And I don't just willy-nilly execute just any old series of steps. I have a well-calculated plan to execute that will give me the answer to my question based on observation in a series of steps that will prove my hypothesis to be correct or incorrect. So step number 3 of the scientific method is conduct an experiment. So I conducted an experiment, and so basically what I'm going to do is I'm going to take some water, not coffee, because water is cheaper than coffee, and this is where we get into the economics of chemistry here. Basically, I could use coffee, but A, it's more expensive than water is. I can get water from the tap. And then 2, I can't see the sugar dissolve inside the coffee because it's not clear, it's opaque. And so I think water is going to be a better choice of solvent in this case. And more importantly, and then plus in relation to coffee, coffee is mostly water, right? So you can basically say that it's a good substitute, right? And so I'm going to dissolve sugar in water, see how fast it dissolves with respect to the temperature change, and then that'll help me answer my hypothesis. So check this out. I'm going to illustrate. So I have 3 cups or containers. One's cold, one's room temperature, one's hot. And I'm referring to the liquid that's in these containers. Before we continue on with the experiment, and what we do after we conduct the experiment, we need to talk about variables. And there are 3 types of variables in the experiment that we'll be conducting. These are the 3 variables that must be in any sort of experiment, no matter how simple, no matter how complex. So you have your controlled variable, you have your independent variable, you have your dependent variable. So what a controlled variable is, controlled variables are the things in the experiment we keep intentionally constant and consistent. And so, for example, we want to have the same brand of cup. The cup must be the same size, same amount of water, same amount of the same source of the water, same brand of sugar, things of that nature, same amount of sugar, so on and so forth. Because if we have, in relation to the independent variable, which is the variable that we intentionally manipulate, so the independent variable in this case is going to be the temperature. If we have more than one independent variable, then we can't attribute the result to any one thing. So if we have the change in temperature and also the change in the brand of cup, we can't say like, oh no, it's the temperature that caused it. We could be like, oh, it was the cup, and we can't argue against that. And so we have to only manipulate one variable at a time. So our dependent variable is going to be how fast the sugar dissolves. Independent variables are temperature. Dependent variable, which we cannot control, is how fast the sugar dissolves. We can't control it, but we can measure it. Keep that in mind. Crazy to think that this all started with me wondering why I can feel granulated sugar in a cold cup of coffee, but I can't feel it in a hot cup of coffee, right? It's crazy how my mind works, or how the mind works. Anyways, continuing on. Step 4, after we conduct the experiment, we analyze the data. And I want you to keep in mind that data is dumb. Data is just a series of measurements that you conducted. It's dumb. We have to use our brains and make sense of the data. And so, also want to say that with each measurement, for each cup, we measured 3 to 5 times on how fast the sugar dissolves in each type of cup we have. So for the cup, we're going to run it 3 times. For the room temperature, we're going to run it 3 times. We're going to run it 3 times. And for the hot water, we're going to dissolve sugar in the water and see how fast it dissolves 3 times, for a total of 9 times. So we analyze the data, and we make sense of the data, and we look at our data and say, I'm just going to make up some numbers. And so we have the container. I abbreviated that obviously for the cold, room temperature, hot. Time for trial 1. It should be a lowercase t, my bad. Time 1, time 2, and time 3. I'm just going to make up some numbers because I know the result of the experiment. And so this is the data that we've come up with. And based on the data, it looks like the cold water, it took the sugar to dissolve in the cold water the longest time. Room temperature water is the medium, and the hot is it dissolved really quick. And so take the average time of the 3 trials. Have 7, 4.33 seconds, and then 2 seconds. Keep in mind the time's in seconds here. Whatever, I mean, it's in seconds. The units are really important. I can't ignore that. Okay, I'm not gonna lie, I can't ignore that. And so this is what we come up with. Analyze the data. This is what we come up with. And so we come up with a conclusion based on the data. We say, look, we've got our data. This is what we did. This is why we did it. And we say, look. Step number 5, conclusion. We ask ourselves, was our hypothesis correct? And hey, man, I don't know. I'm just the nicest guy on the block. No, I'm just playing. But yeah, the hypothesis we made up was correct. This is an experiment that's been done several times. It's the most basic experiment you can do. Our hypothesis was correct. So we say, in conclusion, if we increase the temperature of the liquid, then the sugar will dissolve at a faster rate. I'm going to write that down. So, once again, in conclusion, if the temperature is increased, the sugar will dissolve in the liquid at a faster rate. Smiley face, because it's happy time. It's chemistry, baby. Talk to us. And so, I just want to make another note, is that we want to refer to things in the third person. We don't really want to use second or first person, because that takes away from the experiment. Our experiment is designed to be objective, and we don't want to attribute any characteristics of it to us, because we want it to be replicable. And so this brings us to number 6 steps. And this is my favorite step, because I think oftentimes science is viewed as someone who just... A scientist is viewed as someone who just sits in the lab all day, doesn't really talk to anybody, doesn't confer with, consult anybody on how to do things, but that's not true. We communicate data after we conduct an experiment and say, hey, this is what we did, this is what we got, this is why we did it. And you should get the same results too if you do the same thing. And so the sign of a good experiment and the experiment being accurate is results being replicable. And so I'm not saying that if we're in if I'm in Georgia and someone else is in New York, they should get these exact same numbers, but the trend should be very similar. If everything goes correct and we're in the same lab, I really do expect them to get the same numbers. And so if they're not, then that means my process is off or their process is off, or we need to reconfer about what's going on and how we can come up to the same conclusion. So that's basically the sum up of the scientific method. I just want to reiterate verbally the steps. Number 1, ask a question based on observation. Number 2, form a hypothesis. Number 3, conduct an experiment which has 3 variables: controlled, independent, and dependent. And in this experiment, our independent variable was the temperature change, and our dependent variable was time. Number 4, analyze the data. Number 6, form a conclusion. Number 5, form a conclusion. Was our hypothesis correct? And in this case, it was. And number 6, communicate data to other scientists or other people, and the results should be replicable. So this is once again Sean from Create Your Lifestyle Academy. This is the beginning of a mini series of tutorials. So if you like what you saw, please leave a comment, hit that subscribe button. Let me know what you would like to see in chemistry, and I can make that happen for you. Thank you so much for your time, and I'm just encouraging you to live your best life.